Continuing on with our exploration of Python, we're going to take a look at the loop structures that are available to us. The first one is called the while loop. And the idea of a loop is simply to have a small section, well, it doesn't always have to be small, but a section of code which repeats itself over and over and again until some particular condition is evaluated that allows us to exit the loop. So what we're talking about here in very simple syntax is while some condition is true, and a condition, it can be something as simple as x less than or equal to 10, then we'll execute this block of statements that's below that. Here's a quick example. This is something actually that's quite useful, and you can do this to accommodate a number of different issues in the programming world. Here's an idea where we set up a variable equal to 1, and we say while that number is less than or equal to 5, execute the following statements. So as long as this condition is true, then this code will get executed, and then it'll loop back up to the top of the code and evaluate the condition again until it actually turns false, and then it drops out and continues on with the rest of the code. So in practice, it would work like this. We set up num equal to 1, while num less than or equal to 5, that is true because num is 1, print the number, and then increment it by 1, and then go back up and reevaluate it. So the first time through, it prints 1. The second time through, it prints 2, and then 3, and 4, and 5. And the last time through, once it's been incremented to 6, it'll come up here. This condition will then turn to false, and it'll fall out of the loop. Now you'll notice that there is no ending syntax here. A lot of programming languages will put in curly brace, open curly brace here, and they'll close it with a curly brace, which is visually is kind of helpful, but with Python you just have to remember it's the indentation, the white space, that makes the difference. So here we have a simple flow chart that displays the whole idea of a while loop. Same thing we just looked at. Set up the initial value of 1, evaluate if it's less than or equal to 5. If it's true, do something. Finally, we increase our counter by 1, go back up and reevaluate it. Once it's false, it exits out of the loop and drives on. The while loop is useful for a lot of different things. One thing that it can do is do input validation. This particular program has to deal with looking for some specific responses. So we want responses that are either 1, 2, or 3, and these are strings, notice, because they've got quotes around them. This is a second variable called response, singular, not plural, which is equal to, set equal to the characters 0. So our while loop says while response not in responses, and this is a little syntactically a little more challenging thing to wrap your head around, but it makes sense if you just think about it from an English standpoint. While 0 is not in this list up here, we actually ask a user to input one of these characters, 1, 2, or 3, and we assign that to the response variable. So if the response equals 1, we're going to simply print plastics. There's our familiar else if statement. If the response is 2, we're going to do something else. Else if the response is 3, we're going to print a third movie quote. So as we roll through this, look at how this plays. So we could do our initial print statement up at the top, prints out down here. Then we ask for a number, input, enter a whole number. So the user puts in 1, but they spell it out instead of giving an actual character value. This is obviously not what we were looking for. And so since it doesn't meet one of these conditions of 1, 2, or 3, it falls out the bottom of the loop and just goes back up and starts over again. So all it does is simply says, well, that was useless. It doesn't print an error message. It doesn't print in any of these responses. It just goes back and starts over again, which can be a useful thing when you're trying to evaluate input. Because if somebody puts in something a little funky, it's not what you were looking for, you just ask them to, try again, basically. So this time we put in 5. 5 also is not one of the values up here in responses. So it falls out, doesn't do anything, and starts over again. This time we get some correct input. 2 does, in fact, one of the values in responses, right? And so it prints this condition evaluates to true, and so it prints rosebud. So that's a quick example of how we can do some input validation, and this will be useful as you're looking at some of our programming exercises that we're going to have to do, the rock, paper, scissors, as well as the quiz game. All right, here's a numeric version while doing some math type of things. It's always useful to set up some of your values, your variables, and initialize them to 0 in the beginning. Here's count and total being set to 0. Print statement to tell the user how to terminate the program. And then we do some input. We're asking for a non-negative number. Notice the eval statement here, which forces the input into a numeric variable, which we happen to call num. It could be called a or b or I or whatever you wanted. So we set num equal to the minimum and, well, num equal to the max. So we're initializing these to 0. Now we're saying while num is not equal to -1, because that's our exit condition. Remember, this is the exit condition. So always remember that what's in the condition that's being evaluated here is typically the exit condition. So while num is not equal to a -1, we're going to increment count. So keep track of how many times we've been through the loop. That'll be a useful thing for many things that you're trying to do. Then we're going to add the number to our total. And then we're going to check and see if our current number is less than min. And if it is, then we'll make it the new min number. If our current number is greater than max, then we're going to make it the new max because we haven't, it increases our max value. And then lastly, we actually, are asking for some input from the user again so we can go back through the loop. So let's take a look at how this plays out here. The last part of it is monitoring the count variable. We're still in the loop, all right? Notice your indentation. We're in a while, so we're still inside the loop. Or are we? No, let's see. I don't believe we are. I think that this should still be indented here. So if the count is greater than 0, no, we're outside. We are in part. We are outside the loop. So the loop has been closed because we met our eventual condition, because this will continue to repeat as long as the user continues to enter numbers that are not -1. So the last part of the code is we're making sure that we had at least one entry. I mean, if we didn't have any entries, it would be difficult to calculate the minimum and the maximum and an average. And then we simply do the output statements here and a little bit of math to calculate the average. Otherwise, we print no non-negative numbers were entered. And so this is how it runs. It's asking you to enter a non-negative number. You do that, you do another one, you do that, you do this to exit, and then it calculates the rest of the results. So the while loop is a very simple thing to implement, and it's very useful in a lot of things. Now here's another example using a list. Now this is very applicable to what we're going to do with the quiz game. So You want to refer back to this. We set up an empty list. In this case, we happen to be using numbers, whereas in the quiz game we'd use strings instead of numbers, but it doesn't matter. You're setting up a list. You're providing some way for the user to get out of the program. You're inputting some additional information, and then you're saying, while we're not equal to that exit condition, take your list and append something to it, and then ask for some more information or another answer, go back and evaluate it. And if the exit condition is, as long as this remains true, we keep going through the loop until this is false, hence the negation here. Okay, sometimes it makes sense to say something equal or less than. Sometimes it makes more sense to say not equal. Just depends on what you're trying to do inside the loop. And then we go through using a simple if-else statement. Notice we're checking to see how many entries were accumulated in the list here. So list 1 was growing. The more times we loop through this, we kept appending data to the list. Now down here, we're determining how many items are in that list by using the length variable or length function. So in other words, if you wanted to, you could say my count equal length of the list, and that would tell you, how many entries were in the list. Now here they're doing a little sort on the list and then printing out some of the elements of the list. In this case, it's the minimum, which would be the first element in the list because they sorted it. And then this is the last element in the list. Remember, reading from right to left when you use the -1. So that's going to be the largest value or the max. And then they do a simple calculation here. All right, here's another quick one, just checking bank deposits and trying to figure out when you're a millionaire. You start out at the beginning with 0 for the number of years. Your balance is whatever your initial deposit was. So we're saying while the balance is less than $1 million, then let's increment the balance by an interest value, 0.044% times the balance. So each time we roll through the loop, we're going to take our balance, we're going to add a little bit of interest to it and assign it back to the balance. And then we're going to increment the number of years. So this will go around and around and around until our balance finally makes it to $1 million. And then it'll exit. At that point, we'll be able to print out however many number of years, which is how many times we've gone through the loop. And at that point, we'll have $1 million. So that's another short example of how a loop is useful for calculating a cycle of things over and over again. Now there are times when you want to be able to break out of the loop. A menu is a good example of where you might want to do that. The break statement is how you do that. The loop immediately terminates that, and typically it's done in the if-else statement. Here's an example of using a break. We're going to set up trying to get a list of numbers is what we're after with the code here. So we set up an empty list, and while this is true, notice this is another way to evaluate an expression. It's just saying, while this is true. In other words, if nothing is going to change this from being true, so this is going to loop endlessly until something causes it to break out. So we're going to say, give me a non-negative number, and as long as that is non-negative, we'll go through the loop. But as soon as it becomes a negative number, we're going to break out of the loop. So this will simply run on and on and on and on until a user presses -1. So it's a way to, for instance, a menu kind of a system where you want to continually provide a user with choices in a menu until they decide they want to exit. And this is the flow chart for the break statement. Very basic. The opposite of the break is something called continue. This is also done inside of a while loop, and it allows you to, let's say, jump to the top of the loop. Would simply be used where it's most often used, because a lot of times as you're going through a section of code, you're going to get to some point where it's not necessary to execute the remaining code. You just need to go back to the top of the list, or top of the loop, and start the next iteration. And the continue statement is what's useful for doing that. In other words, skip to the next item. This particular code is trying to find integers that are divisible by 11. It has a bunch of things in a list, so it's going to test each one of these things to see if it's divisible by 11. It sets up an initial increment variable here that's just used right here. So I set initially to 0, while I is less than the length of the list. In other words, we haven't got to the end of the list yet. Set x equal to that particular list element, and then increment your counter variable if you're going through the loop, and then say, if this is, if not, is instance x an integer? So let's look at this. And we're saying, is the instance of x an integer? Well, for this one, it's going to be false. That's going to be true. That's going to be false, because we're looking at these elements trying to determine, are they an integer? If it's not an integer, then there's no sense trying to do divide by 11, because that'll just cause it to create an error condition. So if we just want to continue, we want to go back up to the top of the list and not execute this code down here. So that's where the continue statement can be particularly useful to evaluate certain conditions that might potentially cause an error in your code, and then skip over them and go back to the top of the list. Now, I mentioned earlier that the while statement is particularly useful for doing a menu, and here's a good example of that, and something you'll probably want to implement within your programming examples when you're doing the rock, paper, scissors game, as well as the quiz example. So here you're setting up your menu. You're simply printing the information out to the user, and then you're saying while true, which means forever. Take a selection from the user, and then depending on what they input, 1, 2, 3, or 4, go run some code. And then finally, if they enter something that's none of these numbers, we're using the last condition to break. Well, that's not true. The 4 is quit, so on the condition of 4, we're breaking. Now, one thing you have to be careful when you're doing something like this is what happens if somebody puts in something that is none of these. Your own bad input. If they hit Q to exit instead of 1, 2, 3, or 4, your code will need to take that sort of thing into account. And there's the actual results of having that run that particular statement. So the infinite loop, you can have an infinite loop, always true, while true, or this just goes on and on and on and on. There's no way to break it except for this, the exit condition that's established here. And the infinite loop, again, the programming, and that's the end of the while loop, and we'll do some examples of that here. I'm going to do a screencast showing Python editor and go through some of these actual things, and you can watch them in action.